So we'll be classifying equations into one of 5 categories. And then in one of those categories is also a subcategory. And if we come to that subcategory, then you've got to be able to classify it in 2 ways at one time. Okay? I'm going to give you the list of categories just so you have them. Okay? The first category is synthesis. The second category, decomposition. The third category is combustion. The fourth category is single displacement. Sometimes you will see single displacement simply called displacement. Sometimes you'll see it called single replacement. And the last major category, that's a 5, 4 and then 5. The last or the fifth major category is double replacement. Now, occasionally I've heard it called double displacement, but most of the time you almost always see double replacement. They sometimes call these ionic, and sometimes they also call them, precipitation. The subcategory comes under double displacement, or double replacement rather, and that subcategory is called acid-base. Acid-base. Acid-base is sometimes called neutralization. By using the term neutralization and precipitation, we break double replacement into 2 separate categories. But I like to think of them as being one category, and this is a subclassification. Okay? Because the way that the atoms move around, or the ions move around, is the same with precipitation and with neutralization. Okay? Got it? No? No? Alright, so let's look at synthesis then. Alright, we're going to define synthesis as putting together simpler compounds or elements into more complex compounds. A lot of things I can't write bigger, I wouldn't be able to fit it on the page. I'll try to write a little bit bigger for you. And there's a general symbolic representation of these synthesis reactions. And that symbolic sort of representation, we just put A as one of the simple compounds, and B as, well, simple compound or element, and B as another simple compound or element, and then those combine into AB, one more complex compound. And here are some examples of synthesis reactions. We're going to symbolically represent them in equation form. So we're going to put together hydrogen gas and oxygen gas, and we're going to form water. Now the equation, to be balanced, needs to have a 2 here and a coefficient 2 here. But this then is A, and this is B, and this is AB. Here's another example of a synthesis reaction. Nitrogen gas plus hydrogen gas, and you make ammonia gas. Oop, I don't want to put that in parentheses, I want to put this in parentheses. So here's A, B, and AB. Of course, I haven't balanced it yet. To balance this, I need a 2 here and a 3 here.
Are those all gases?
Yes, they're all gases. And one more example. Since I just put together 2 elements to make a compound, I want to do something with a couple of compounds here now. We'll put together a couple of simple compounds. Mn, capital N, little n, O. That's manganese oxide, manganese 2 oxide. This is all synthesis, yeah. Well, I hope you can see that it's AB and AB and AB now. And then we've got H2O, and we're going to put those together and make manganese 2 hydroxide. So you can use compounds or elements. That one's already balanced, yeah. All right, do you understand? Is there any question about synthesis and how to recognize it? Okay. Synthesis is simply putting together simpler elements or compounds into more complex forms. Okay? All right, let's do decomposition now. Decomposition can be thought of as the reverse or opposite of synthesis. Okay? In decomposition, you take complex formulas or compounds and break them down to two or more simple formulas. That'd be good to say. Sure, reverse of synthesis, okay? All right, so the general sort of illustration example of decomposition has AB breaking up into A plus B. Examples: CaCO3 and you heat it up and you get calcium oxide and you get carbon dioxide gas. That's a G over here. Here, S and S. So I hope that you can see that you have an AB form that becomes A and B. Now please don't confuse the fact that the oxygen appears in both these two forms. We're breaking this apart into simpler compounds. Does that make sense? Okay, so here's another example. CaOH in parentheses 2 yields CaO with an S physical state symbol, solid, H2O, and gas is the physical state on the water. So this is being heated up as well. When you see AB yields A plus B, don't confuse it that it has to be cleanly A separate from B. I mean, it's not going to split up necessarily cleanly. The main thing is we're taking a more complex form and breaking it down into simpler forms. Two or more simpler forms, okay? All right. Combustion we've seen before.